All right. Greetings, this time in video. Do I look better in video or in person? I don't know. At least I won't get any older in this medium. Anyway, so this video is our starting point for discussing positive externalities, positive spillovers, spillover benefits. Has a lot of different names. Sorry about that. But if this is going to do you any good, I need to name all of the common names for it. So when somebody talks about it in the real world, you say, oh, I learned about that at ECO 2023 at UTSA. I remember that. Yeah, my instructor called it such and such. But it's the same thing. All right, so what are the sorts of things that generate positive externalities, and why is there a chapter in our book devoted to them? Why do we need to understand them? Well, this is another example of market failure. Wow, that sounds like a terrible thing. Again, remember, that just means failure to achieve maximum efficiency through the free market mechanism. All right, does that mean we should intervene? Does that mean that because we haven't achieved maximum efficiency, that government intervention is going to do even better? Well, you'll see, I think, from my list that I might put up on the screen in a second, that some of the things on that list are important enough that the government mechanism with all its inherent problems is something we need to deploy. Other items on the list, you might say, yeah, it does fit that definition of generating benefits to third parties, but not enough of them, not big enough, not consequential enough to tax somebody to pay the subsidies that are called for by positive externalities, and to create government agencies and all of the attendant risks of when we put force into the equation. Remember, that's what George Washington said about government. It's just force, and indeed, that's what it is. The government is our collective decision-making process where it's the law when we come to a determination, and laws are enforced by force. They have to be, otherwise they have no meaning. All right, so here is the list, and I'm a little wacky here with these lists because everything to me is backwards. So I'm trying to hide and stay on the screen and get everything this right, and it'll take me a minute to get coordinated, get my fingers out of the way of everything. So you have an advantage out there in video land. I can yank this away and put it back, and you can say, you rascal. It's what you'd say if I was in class. I didn't have a chance to copy that. But that's not a problem here, because you can freeze the frame and get all of this down. All right, so your textbook has several examples, right? And there's no reason for me to regurgitate those. Your textbook does a good job of explaining those. There are many others. I've got a few of them on my list here. And I would argue that some of these are policy relevant. In other words, worthy of government intervention, despite the fact that the government isn't any more perfect and often less so than the market mechanism. All right, so for example, contagious disease inoculations yield what I have at the very bottom there, MSB greater than MPB. That hieroglyphics that you've been seeing all semester long. I am trying to stay on the screen while putting this up here. And I think I'll get rid of this so I can stay in the middle of the screen. You see the MSB over greater than MPB? We'll put the model up there in a minute, that supply and demand model that since the last chapter has grown to 3 lines rather than just 2. All right, so the textbook has some examples. There's contagious disease inoculations, MSB greater than MPB. Outdoor Christmas lights, MSB greater than MPB. Front yard landscaping, MSB greater than MPB. Okay, so all of those things. I'm going to spend a little bit more time with item F later on, so I'll put the list back up there. But you've got the list. Now, it's on the video, and you can fast forward or rewind or whatever and freeze the screen to get that list copied if you want to. All right, so why am I arguing that contagious disease inoculation is a policy relevant positive externality, or if you look carefully at the top of the good, a merit good. A merit good means that not enough of it's going to be provided just by a free market mechanism. And again, our model will nail that down in a few minutes. So policy relevant. Positive spillovers. When you go get a disease inoculation for a contagious disease, not only are you benefiting yourself, but you're less likely to transmit the disease to others, and so you'll be benefiting other folks. Okay, so that's pretty significant, right? And depending on the nature of the disease and how nasty it is, we might want to make sure that a lot more people get these inoculations than would just based on their perception of their own personal benefit. Okay, so that might require us to subsidize the activity. Again, before I put the graph up here to show what the subsidy is or how big it should be, let's look at the other two items, the next two items on the list. Go back up there for just a second. Outdoor Christmas lights. Yes, your neighbors benefit. Oh, yes, and front yard landscaping. Yes, your neighbors benefit when you put nice flowers and other kinds of nice landscaping in your front yard. Yes, your neighbors and passersby benefit when you put Christmas lights out where other people can see them. Did they help you put up the Christmas lights? Did they help with the landscaping? Did they help pay for any of that? No. So they're getting a freebie, a free ride. And so because you're not compensated for delivering all these benefits to others, you won't do as much as you might otherwise have, and others won't do anything at all. And so that's a negative, but I'm not sure it's a big enough negative for Christmas lights. I love Christmas lights. I'm not sure. I wish more people would put them out. I'd be willing to pay a little bit into a common pot to help them out if that would yield a lot more Christmas lights that time of year. Others, maybe not so much so. And that's why we have a political process to sort those things out. Okay, but front yard landscaping, same backyard landscaping, no positive externalities. You're the only one that's going to benefit from that. Front yard, your neighbors will benefit. It'll benefit their property values. That'll benefit the city and additional property tax revenues. All right, so spillover benefits to the rest of society. All right, but again, I'm not sure the consequences of having a suboptimal amount of that are drastic enough to merit the governmental processes and their costs and risks that would be required to achieve the optimal level. Q star, marginal social benefit equals marginal social cost amount of those things. Disease inoculations? Yeah, maybe. Again, depending on exactly what the contagious disease it is and how devastating it is. Maybe it's fatal to some people, maybe to a lot of people. You might remember from history, the plague in the Middle Ages, 3/4 of the people in Europe were killed by the plague. Maybe if they'd had said disease inoculation against that and they'd gotten everybody that was still alive at the time to get that and be less spreading, that might have saved a couple tens of millions of lives, maybe more than that. All right, so some positive externalities are policy relevant, meriting government intervention, some are not. Let me put up the graph now that establishes the model for this, and there it is again. In case I yank it out too fast, you can always come back to this spot in the video. Right, so MSB is above and to the right of MPB. The equilibrium amount of anything is where the MPB, the marginal private benefit, equals the marginal private cost. So if left to its own devices and we don't intervene with the government, the quantity QE will occur naturally. The efficient quantity is Q star, a larger amount. So if we only have QE, if we have no government intervention, just allow the free market to function, we'll have a deadweight loss. And I don't want to mess this graph up, so I'll show that in a later graph. But the optimal price is higher, and the optimal quantity is higher than would result from a free market if we subsidize it. Okay, and let me put up some of that here in a minute. Okay, I'm trying to shuffle through my slides, and I can't find the one I want to put up. If we subsidize it, we can, and we subsidize it equal to MSB minus MPB, we'll shift the equilibrium to the optimum. Sounding familiar from the last chapter? See there, we talked about negative externalities, and we had MSC, something that looked like the supply line. Above the true supply line was MPC, marginal private cost. So you notice here with supply, we're saying for W, no negative externalities, just positive. Focus on one thing at a time here in the course. The deadweight loss, the measure of how inefficient the market outcome is going to be from underproduction, whereas last chapter was from overproduction. All right, so let me just shuffle through my slides real quick and get back to where we want to be here. Okay, so let's see. Oh, okay, so we had this one. That's an old one. Okay, and let me see here. We want to go to, oh yes, here's the one that I wanted to find. Okay, so marginal external benefit is equal to the difference between those two lines you just saw on this graph, right? This graph right here. Okay, so on that particular graph, MSB and MPB were parallel lines. So MEB, marginal external benefit, the benefit to others other than the person choosing whether to buy or not, is constant. But it isn't always that case. But for our purposes, it will be, just to keep focused on the key central issue. For efficiency, which means to get QE equal to Q star, we should have a subsidy. Okay, S star would be the optimal size subsidy, which would be equal to whatever marginal external benefit is at the optimum, which in our case is the same at the optimum and everywhere else, because MSB and MPB are the same distance apart at all quantities. That will increase the price, which is what will increase the quantity supplied. But at the same time, it decreases the purchaser cost because of the subsidy. All right, so let's just show how that looks with another drawing of the graph, this time with some numbers, right? So we have the general graph right there, right? You've got that from a previous slide. And now we have the more specific graph. It's the same thing, but we got some numbers on it, so we can derive some results and create some examples for you to work through for yourself and to refer to when you have some homework questions that demand exactly the same thing. So recounting what we did with the orange sheet of paper, the basic model, if the government doesn't intervene, the equilibrium price will be $4.50 a ton, and the equilibrium quantity will be 100 tons a year. And the marginal external benefit is 3, right? Not because the supply line starts at 3. I drew this graph. Oh, no. Too many 3s here, but I decided not to redraw it. So where does the 3 come from? That's the marginal external benefit. It comes from the fact that the MSB and MPB are 3 apart, which we can readily see from the starting point of both lines. The MSB tops out at 10 and the MPB tops out at 7, right? And at the equilibrium, the MPB is 4.5 and the MSB is $3 more at 7.5. So per ton, there's $3 of benefits that spill over onto society beyond the person making the purchase choice. All right, and so we'll have a deadweight loss equal to $120 per year, okay, if there's no intervention. So $120 a year is sort of a measure of whether we should intervene. If the intervention, including how we value various risks of government programs going awry and turning into things that we don't want them to turn into, which is a real risk, $120 a year, it better cost less than that, or this kind of intervention isn't worth doing, because that's the cost per year of having the equilibrium be below the optimum, $120. So where does that come from? A later slide will write down the exact equations, but it comes from the fact that we're 80 below the optimum. We're at 100, equilibrium should be at 180. And so we have this triangle here, right? Right, that triangle right there. I'm trying to overcome this notion of being backwards, is the deadweight loss triangle. Let me go ahead and just scribble it in there for you. Okay, I should have done that before. Get the wrong pen out of my pocket here. DWL. Okay, so the deadweight loss triangle is always where you are versus where you should be, and it's the difference between marginal social benefit and marginal social cost at the equilibrium quantity. Okay, so it would be 3, 7.5 minus 4.5 is 3, times 80. 180 minus 100 is 80, divided by 2, because it's a triangle, so 240 divided by 2 is the 120. Okay, so let's see, how much would this subsidy cost? Okay, taxes have to generate the money for the subsidy, which, by the way, isn't taken account of here. If we levy a tax, which we know from earlier in the semester yields a deadweight loss, and collecting the money for the subsidy costs more than the deadweight loss that it eliminates, well, that's yet another reason to leave this alone and suffer the equilibrium being below the optimum. Anyway, so how much money would have to be raised to finance the $3 optimal subsidy? $540 per year. How do we know that? Well, in the new equilibrium, the one we desire because it's the optimum at Q star, quantity is 180. 180 times 3 is 540. Okay, so a $540 subsidy will eliminate a $120 deadweight loss. The additional output, right, from 100 to 180 is worth more than the cost to society by $120. Now, we do have to pay the subsidy to everybody, and we have to pay it on the first 100 that would have occurred without the subsidy. All right, so anyway, let me flash up the basic model again, just so you have the starting point from which to mess around with this on your graph paper, right? And explore and put different numbers on there and play what if. Remember, that's how you learn. Play what if, manipulate, ask questions, talk about shifts, what ifs. Said the what ifs already, didn't I? All right, so let's see. All right, so we have our, let's see, did we get that up there? All right, for efficiency. Yeah, okay, we had that up there. Put all those up there again. Okay, positive externalities. Let me put this back up here again. Okay, examples. Let's go back down to the two at the very bottom. Exterior house maintenance. Is that policy relevant? I don't know. It could be. You know, if we don't incentivize people to take care of the outside of their house, the whole neighborhood could look run down. Is it enough for people to take pride in their own homes, or do they need a little jolt beyond that? Interesting policy question. Intelligent people will disagree. Not much disagreement on the last item. Schooling is widely subsidized, even at the higher ed level, where most of the benefits go to you in terms of your better career earnings. But it's still argued that society as a whole gets some of the benefit of you pursuing your education, and so it is subsidized. Note that a lot of people call schooling a public good. It's confusing because it isn't a public good. It's a merit good, right? So we're not saying anything negative about public schooling or schooling in general by saying it's not a public good. It doesn't meet the definition that we ascribe to public goods. And to segue to that, okay, so before we segue on to exactly what a public good is, MSB greater than MPB means that we can and should probably, that it is a policy relevant spillover benefit situation, that schooling does deserve subsidy, even though it's not a public good. It's a merit good, right? And merit goods deserve subsidy. Okay, so then what is a public good that schooling is not? Now let's go to this slide here, which again, in case I yank it out of the way before you copied the whole thing. In fact, maybe you should just pay attention right now and copy it later by going back to this part of the video and freezing it. Okay, so we've talked about this thing at the bottom. Private good with MSB greater than MPB. That's a merit good, right? So a private good is exclusive and rival according to this matrix, right? What does that mean? Exclusive and rival means that you can preclude others from having it if it's yours, right? By buying it, it is exclusively yours. You can exclude other users of it. It is your property. And rival means that if you consume it, it's not available for anybody else to consume. Use uses it up, right? You might think, well, duh. Well, that's because most things are private goods. For most things, use does use it up. But there's two examples of non-rivalry. And one of those is, in fact, public goods. True public goods, like lighthouses on rocky promontories sticking out into the ocean, the light from that is a public good. One ship seeing it and thus avoiding crashing into the rocks doesn't preclude any other ships from seeing it. So it's non-rival. The use of the light, the benefiting from that service by one ship doesn't diminish the service to others. Now you might argue at some point that if there's enough ships out there, they might crash into each other, consuming the light rather than crashing into the rocks. That's an interesting example, actually. Usually that's not the case, so we usually don't talk about lighthouses as being quasi-public goods. But you and I will talk about that, because there are important things that are quasi-public goods. Stay tuned for that in a minute. So right now, a lighthouse is definitely non-rival and non-exclusive up to any reasonable use that anybody's ever found. The ocean's big. There's room for a lot of ships out there to simultaneously have 100% of the light without anybody else having any less. Okay, I mean, kind of holding it sideways here, getting in front of my face there. All right, so a lighthouse and national defense, right? The protection, the security that you and I and everybody else in the United States derives from our Army, Navy, and Air Force and other national defense assets is a public good. I'm not defended any less because you're here and anybody else. If somebody shows up in the United States, flies in or boats in, now they're protected too, right? Whether they paid their taxes or not doesn't affect the level at which they're protected. In fact, taxes is the only way we can finance it. We can't say, oh, you didn't pay, you don't get any protection from national defense. Sorry, I meant to wag my finger there and it wasn't on the screen, right? So national defense is non-exclusive. You can't exclude non-payers. So we can't say, you got paid protected by national defense this year, ante up, or we're not going to protect you anymore. We can't deny that protection once it exists, right? So it's non-exclusive and non-rival. Is that true for a public school? Right? No, it's not true. No, it's true we don't exclude anybody from it, but we could, right? So it is something from which we could exclude people. Schooling can be denied to those who do not pay. You know that, right? You got to pay your tuition. You might be able to sneak on campus and go to a classroom. Nobody would detect you, but you wouldn't get any credit for the course, right? So there would be no official record of having learned anything, which is a big measure of what it's worth. All right, so national defense and a lighthouse, two examples of a true public good. Education is not only not non-exclusive, it is exclusive. By that it means we could exclude people from it. Private schools are proof of that, right? You no pay, you no go, right? So doesn't mean we want to exclude, we can. And it is rival in consumption beyond the classroom level. More students means we have to provide more of it, right? The space is an issue. Now within a classroom, up to the capacity of the classroom, instruction is a quasi-public good, which means it's subject to congestion. Okay, but let me get to the quasi-public goods in a minute. Let me go back to this matrix. So first of all, public goods are non-exclusive and non-rival. They're not used up by use, and we can't exclude people from them based on payment or non-payment, which means that we have to finance them through taxes. That doesn't mean we have to provide them to the government, but the government has to finance them through taxation. Maybe they can be privately provided through bid on contract, and then the government contracts good. Well, we don't want to do that for defense because we don't want to have somebody for profit wielding all those guns and missiles and all of that. But for some other things, that's perfectly acceptable to contract out the actual provision of a public good, but not the financing of it. We have to collect that through taxes. All right, and then there's the non-rival exclusive category where it says club goods. That's like Netflix or XM radio. You can be excluded from it. But once it exists, your use of it doesn't diminish anybody else's availability. Okay? So you signing on to XM radio doesn't make that signal any less available to anybody else. But if you don't pay the subscription fee, you get cut off. All right, so that's all we're going to say about non-exclusive, non-rival, just an explanation of what they are and an example. We're going to say a little bit more about common property. Okay, non-exclusive and rival. One of the reasons is that here in San Antonio, we're sitting over a very important example of that. It's called the Edwards Aquifer. Underground water is an example of a non-exclusive but rival in consumption commodity, right? If you use some of the water underground, there's less of it there, right? So it's rival in consumption. But Texas law everywhere but here, and for a long time everywhere, said if you had a piece of property, you could suck all the groundwater out of the ground that you wanted. That became unviable here because growth pushed us to the point where if we let everybody have unlimited pumping, the aquifer would be drawn down unacceptably fast and the springs would go dry. And so we changed the law to make this part of Texas an exception to where we said, hey, water is too scarce here. We can't sustain unlimited pumping here because of the rivalry in consumption. All right, so just some mention of quasi-public goods. Let me shuffle through my slides. They've gotten mixed up here. Okay, so you saw that one, positive externalities. Got that one, got that one, got that one. All right, so here we go. Okay, so at the classroom level, instruction is a quasi-public good. What does that mean? Well, that means up to a point, it's non-rival and non-exclusive. Okay, so if you can get in the classroom, like there are no guards at UTSA, so you can figure out a place to park your car or pay for the parking, You can walk up to a classroom and go in and sit there. Okay, so up to the point where there's no more places to sit. And so, see, that's the point at which congestion creates rivalry and consumption. If it's crowded enough in there, the delivery of the product, the instruction, the professor's explanation of things suddenly becomes rival in consumption because all the big crowd inhibits your absorption of the explanations. But up to that point, if somebody marches into the classroom, it doesn't diminish your uptake of what's being said at all. Okay, so that's what we mean by a quasi-public good. It means that up to some level of use, it's non-excludable, okay, non-exclusive, and non-rival in consumption. But beyond that point, their rivalry sets in because of congestion. What are some other examples? We experience these all the time. Maybe not. Maybe don't go to park all that often. But out here, outside our window, here in San Antonio, there's I-10 and 1604, and we know that at certain times of the day, when you get on the road, you ain't going very fast. You're not going at speed limit, and when you get on the road, you're slowing other people down. Okay, so those are quasi-public goods. Congestion does slow folks down at some level of use. Midnight, public highways, I-10, 1604, wherever you are, the big expressways are pure public goods. You getting on the road at midnight doesn't slow anybody else down. Okay, so there's not any rivalry in consumption at off-peak periods. But at peak periods, by definition, in many cases, there is rivalry in consumption. All right, so Eco 101 says there's a shortage or a slowdown at certain times. Shortage, what does that mean? The price is too low. Where does that lead? You've heard me say this as an example several times this semester. That leads to, according to Eco 101, there should be a fee for driving on the road during congested periods. That would do two things. The marginal drivers, ones that don't want to be on the road all that bad, would say, not worth paying the fee. I'm getting off the road. Everybody else can drive a little faster as a result. And for those who conclude that, yeah, well, I still want to drive on the road. I've got to get to work or want to go somewhere badly enough to slow other folks down a little bit. Pay the fee, and well, the money facilitates expanding the capacity of the road, right? So, congestion fees are suggested by positive economics for quasi-public goods, but only during congested periods. You don't charge the fee 24/7, just during the congested times, and then the money allows expansion of the highway, which doesn't necessarily mean additional lanes, but could. Might just mean more cleanup and keeping the road moving along a little better managed, accidents go away quicker, less construction, especially at bad times, okay, so that the traffic moves better. But at some point, it probably does mean additional lanes if there's continued increase in demand. Okay, so public parks, what does that mean? Maybe charge more on the weekends when there's more folks. That encourages some folks to come during the weekdays and others to say, not worth going. Those that go still get a better experience because it isn't as crowded and they don't waste hours outside standing in line. Remember doing that outside Lost Maples peak time when the fall colors are there? You go there expecting to spend the day viewing fall colors and you spend the first 2 or 3 hours standing in line and you still may not get in, right? Whoops, man, it would have been better to have that congestion fee. Then you're sure of getting in if you want to get in, and you get a good experience or better experience once you get in there. Right? Nevertheless, these policies are not public. We think we've already paid for them. And so, well, we end up with the congestion sometimes when might be a way out. All right, so let's see. Where are we on some of this stuff? Okay, so we want to talk a little bit about the common property issue. We go back to our matrix here. Pile things over here in the corner. Where'd it go? Yes, our matrix. All right, so we've given a little bit of time to public goods. We've given some time to private goods with positive spillovers. We call those merit goods, positive externalities. Right, given some time to that. Only a tiny bit of time to club goods. And, well, private goods, we've been talking about those all semester long, and finally we're talking about, well, not everything's a private good. Okay, there are some things that don't have those critical rivalry exclusive properties that we generally assume for most things, and for most things they are true. All right, so common property. Flash this up here so you can copy this down later, maybe now if you're fast. Okay, open access resources, right? So open access, what does that mean? Non-exclusive. Sometimes that's just by policy choice, right? Our Edwards Aquifer, we've shown that it was open access. It is in most of Texas open access for underground water. See it there at the bottom. Wildlife, same thing. See, now we have hunting licenses because it's shown that there's too much hunting, too much harvesting of wildlife if we don't somehow constrain it. Okay, so open access resources, sometimes just by definition, like to the air and the water, right? It's hard to limit access to it. But in other cases it's easier, but we may not have done it yet or may not want to for whatever reason. All right, so not exclusive but rival, right? Again, the water is, till recently, till a couple decades ago in this area and still in all of the rest of Texas, we don't limit pumping of underground water. A property owner can pump all they want. But that does diminish the amount of underground water, and indeed in much of Texas the ground water is level is shrinking and the land is subsiding over it, and so there's more and more thought for limiting pumping in more and more places. But there is inertia that makes it hard to change established ways of doing things even once they become obsolete. Okay, so you see the second part of this. Growth, increased demand can create unsustainable use, a rush to ruin. Right, so that says that low demand, no problem. So let's consider the wildlife. If there's not many folks around and not much hunting, then it's sustainable because the amount of hunting is just the level of natural replenishment by the animals. But if there's too much hunting, then the animal's natural replenishment is diminished by the fact that we're shrinking the population of adults. And whoops, now we've created some unsustainable use. And if we keep that up, we have what's called the tragedy of the commons, the rush to ruin it. Let me refer you to something at the bottom that says government funds. Think about that a little bit before I go to the model to nail all this down. Government funds, is that an open access resource or common property? Well, by definition, yeah, that's the public treasury. Why is there a rush to ruin, or the suspicion that there might be this rush to ruin? Well, because each representative sees that as an open access resource. If they don't claim it for their district, they know that one of their colleagues in the legislature will claim it for theirs. They know that failing to claim it for their constituents isn't going to leave the money there any more than failing to shoot a buffalo in the Old West would assure that the buffalo would be there to reproduce more buffalo. Somebody else would shoot it, right? So that way of thinking, which is correct in the sense that, yeah, if I don't claim it for a government program that benefits my constituents, one of my colleagues in the legislature will claim it for theirs. So by golly, I better, and everybody's thinking the same thing. So there's enormous pressure to spend every last penny and find more pennies to spend because, well, the money comes from a little bit from everybody that can be focused on the people that elect me. Talking as if I were a legislator, which I'll never be. Okay, so that's why we have a rush to ruin if we have sufficient demand, which is always the case for government funds, on the limited resources, right, that we always have. All right, so there's what it looks like. So here's the first case where we've had the lines not be parallel when there was more than two, okay, or more than two sloping the same way. Now we've got the demand lines parallel, right? So no problem there. Demand is MPC, and no positive externalities here, just MPB is demand. MPC is supply. And sometimes there are negative spillovers, right? And we're back to that from the last chapter, only now the lines aren't parallel like they were in the last chapter. So what does this mean? It means at low levels of demand, okay, like D0, the equilibrium and the optimum are the same thing, right? It's only once we get demand intersecting supply past Q prime. Show where Q prime is, right there. Right, this little thing up there is the prime symbol of an apostrophe. 100 in this case. Nice round number. Right, anytime we have an equilibrium equaling the optimum, right there, below 100 in this case, below Q prime, no problem, no need for government intervention. Everything is fine. The market mechanism is yielding the optimal amount of extraction of V in this case, our mythical open access resource. Once demand gets past where it intersects MPC, in this case at Q prime at 100, like way past with D1, now we have a problem, right? Why we have a problem? Well, because both the equilibrium and the optimum are unsustainable. But boy, the MPC and MSC will shift to the left over time, and we'll reach sustainability. And I want to save that graph for when we meet next time in class, because that needs to be a little bit more interactive, right? But for now, we can see that D1 intersects MPC at a quantity of 160, okay, which is not only unsustainable past 100, right? More than the resource can spit out in the way of renewal, like groundwater inflow or new births of wildlife species, say deer, right? So what we're saying here is that at least 100 tons per year of deer will be born every year. And so if we harvest 100 tons per year of less, then we can just keep doing that forever. But 160 tons means now we're starting to cut into the adult breeding population, and there's going to be fewer and fewer deer to breed additional deer, and so the deer population is going to shrink. And one of the things you conclude from this graph is, well, that's optimal, at least for now. Maybe the demand for deer or whatever V happens to be is so huge that even if we take account of the marginal social costs being higher than the marginal private costs and put things at the optimum, which according to this model is 140, that's still more than 100, and that's still going to shrink the population, but not for very long, because these cost lines are going to shift to the left, okay? And as a result, eventually we'll get back to sustainability, maybe a little less than 100, and maybe at a little higher price. But right now, this graph is saying that the demand is high enough that it's worth drawing down the stock a little bit for now. All right, but 160 is too much, even given the high demand right now. 140 is the optimum. If we don't do anything, if we don't intervene, the equilibrium will be 160, and we'll incur a deadweight loss of, how big is that deadweight loss? Let's see. Equilibrium versus optimum, 160 versus 140. Okay, that's 20. And at the equilibrium, the marginal social cost exceed the marginal social benefit by 19 minus 12, 7. So, by the way, this is written down for you in one of the other slides. 7 times 20, okay, 160 minus 40 is 20, and 140 is 20. 7 times 20 is 140, divided by 2 is 70. Okay, so now, how would we correct that? Okay, remember from last chapter, there's two ways to address MSC greater than MPC. One is to bring the two together with a tax or fee, and the other one is just to allow only the optimal amount, in this case 140. All right, so that brings us to our next slide. Okay, and there's that graph you can always go back to with rewind. And here we go. Okay, so there's our DWL with demand at D1. No DWL with demand at D0. No problem there, where the free market yields an equilibrium that's optimal. But D1, no, not the case anymore. Okay, so 160 minus 140, where you are versus where you should be. And then the difference between the marginal social benefits and marginal social costs at the equilibrium. Okay, so 19 minus 12, and then process that together, divide by 2, 70 per year. If you go the tax or fee route, T star for the tax, F star for the fee, pretty much interchangeable terms. It means some dollar amount per unit, ton in this case. And so at Q star is where you find T star and F star, MSC minus MPC at the optimal Q star, okay, 140. 15 minus 10 means a $5 per 10 fee should be charged. That will cause 20 tons per year less to be taken and generate 5 times 140, which is 5 times $700 per year, and revenue to do various good things, including maybe compensate those who are driven off of the resource by the higher cost. Okay, and the alternative to that would be just to specify 140 tons per year as the allowable amount and let the holders of that, however they're chosen, and that's the tough part of this solution, is how do you choose who gets how much of that 140. But let the 140 be freely saleable among the holders, and then the amount of the allowable catch will move to those who are most efficient at catching or harvesting the resource. And notice it says down there something we just talked about again a minute ago. Q star is still more than the Q prime that's sustainable. Yes, it is temporarily efficient sometimes to harvest more than a sustainable amount. All right, so wow, I mean I raced through this. I would not have talked nearly this fast in class, right? But I can't see anybody with raised hands. All right, so what does that mean? Well, that means go back through some of this. I know I talked fast. Slow it down, digest it in pieces. And you don't want to forget your clarification needs. Scribble them down. Scribble them down. Okay, and go online now to record some of them in online BB Learn forums. You don't need to do that. You can save them for class. But it'll guarantee if you put them in the forums that I'll address them probably before I get to class, before we chat again. But it'll also guarantee you'll forget to raise the issue, and you'll want to be on the homework or the exam. Say, doggone it, I remember that from the slides, and I didn't get that. I didn't go right away to record my clarification need, and now I have a clarification need, but it's the middle of the exam, and I can't do anything about it. So, oops. No, you don't want to do that. All right, so these videos are great. First of all, they allow me to not be here today, and sometimes that's an imperative. Second, they allow you not to be here today, and I know one of the uses of this video is to not have class the day before Thanksgiving. Some of you would do your marginal analysis, and you'd weigh the marginal benefits and costs, and you'd choose, perhaps foolishly, even if I held class today, to be somewhere else, right? And so now I'm letting you do that without having to miss class. But do watch this video carefully. Maybe watch it more than once. Watch it slowly. Stop and write some things down before letting it move on. Go to the BB Learn forums to record some clarification needs. And by all means, bring them to class, because we're not done talking about this. I'm going to talk a little bit more about this graph and how initially unsustainable behavior, namely, say, an allowance of 140, which still has marginal social costs above marginal private costs, which means that we're increasing the harvest costs over time by drawing down the number of things that there are available to harvest and reproduce. Okay, well, over time, move us to sustainability, but there's a cost to temporarily unsustainable behavior, namely longer-term costs, and maybe the long run having to back off and letting the stock rebuild itself later on. Anyway, you're thinking, wow, that's a lot of it. Don't worry about this last part. We're going to talk about that in class. But some of the basics, hopefully you can digest them from the book and from this. And to the extent that you can't, this is awesome. I mean, it's not awesome that you can't. But the fact that we have this mixture, right, your ability to watch this video as slow as you want to, and then to talk about it in class on top of that, and online on top of that, new technology is great. Allows us to nail it down if we want to. Remember, the fun never ends. Get my finger wagging. Just had it up below the screen. The fun never ends unless you let it. Don't let it by letting stuff stay confusing if it is. Don't allow that. As Bob Newhart would say. If I haven't shown that earlier this semester, Google Bob Newhart, stop it. And for 7 minutes, you'll get a good laugh. But as Bob Newhart would say in that video, stop it! Right? Unproductive behavior. Stop it! Right? All right. See you soon. Thanks.